Um, hey folks, thank you for joining us. This is, I don't know, Alexei, is it the first panel of the session or kind of,
Very
well,
first.
we're the first. Awesome. So this is where the experiments begin, and we'll hopefully, the people on after us will learn from this experience and know what to do better. But this is the first time for, I think, all of us. And so this is my third time of kind of hosting this debate, and I've done it kind of previous occasions. And we have, four wonderful debaters here with us. And the motion that we will be debating is the following: is will AI kill programming? But more specifically, what we will be debating is the following motion: is yeah, let me find it. Have to be prepared. Is AI will become essential to programming over the next decade, as critical to software engineering as development in source code control, continuous integration, and programming languages have been over the past three. So we have two teams of debaters with Brian Cantrell and Helena Edelson arguing the side against, and Omar Alonso and Jean Linetsky, I'm sorry if I butchered anyone's name, apologies, will be arguing for the for side. So instead of maybe kind of me introducing every one of them before you start, and we'll have like 5 minutes on each side to kind of start with the opening statement, maybe start by 30-second introduction of who you are, and from that then kind of continue to our points. So I'll just introduce myself. Like I said, Vitaly Gorin. I'm the CEO of a company named Ferris AI. We're basically, have a slight horse in the race in the sense we're trying to use AI to automate a lot of software engineering tasks, but I will be trying to be as neutral as possible in this regard. Also, just kind of a note, two notes. One is our wonderful debaters are arguing the points, but please, don't hold it personally against them. We just kind of randomly split it into teams where they, it's 4-4, so they don't necessarily, represent very strongly the point that they will be debating about. And the second, this will be an Oxford-style debate, which means we will take a vote at the beginning. And Alexei just posted the link on Discord, so please go in and vote. So we will tally the votes at the beginning, and then we will do another set of voting at the end at a second link that Alexei will post. And the winning team is the team that was able to swing the most votes. And from this, Jean, I believe you are the first debater arguing for the for side. So please introduce yourself and kind of start your motion, and you have kind of 5 minutes on the clock starting now.
Thank you. Thank you, Vitaly. Thanks everyone who's watching and who's participating. My name is Gene. I'm the CTO of the company called True Accord. It's the first company in this country, definitely, or maybe in the world, that is redefining what it means to collect debt, what it means to help consumers close their late payments, late debts. We're using the combination of machine learning and personal conversations with our agents who never collect on consumers, just helping them get out of difficult financial situations. In the last millennium, I was just straightforward coder, first in assembly, then in C++. And starting with this millennium, I started doing startups, did them for a while. One of them was actually with Alexei, of all people. And right now, I'm the CTO of this company for almost a year, and it's definitely the best gig of my career. So on the motion, will AI kill programming? Obviously, without strict definitions of what it means to kill something, what it means to program things, I would say that even the definition of what it means to code, what it means to program, had changed so dramatically over the last, let's say, 30 years that I've been doing it. It used to be that people coded things pretty much from scratch. And even before that, people coded things in assembly with no benefit of accessing anybody else's code, with no benefit of reusing somebody's building blocks to build their solutions. The biggest innovation, I think, in that direction was first the symbolic languages, and then almost everyone is coding in symbolic languages right now. Although there are still people who are coding in assembly, very close to metal. And then what I'm seeing, and maybe your perception is different, what I'm seeing in the last 10 years is that the type of activity that a typical coder, typical programmer is engaged in every day is very different from what it was even 15 years ago. Mostly now, coders build glue between the existing components. To build a working system today means something entirely different from what it meant 15 or 20 years ago. And so in that same sense, I think what it will mean to build a working system 10 years from now will be very different. And the biggest difference will come not from symbolic languages as it did before, but in reliance on more and more of the rules to be produced automatically by intelligent systems. I would say that for several companies, for many companies that we all know who they are, that time had already came. You wouldn't imagine Facebook employing 1 million engineers to write if-then rules that govern every single inclusion of every single post on every single person's feed, right? We have 2 billion people interacting with those systems, billions times a second every single day. And I think this is really the terminal state of any cloud company, for lack of a better definition. It will have some kind of a black box that is learning much faster than any human or any group of humans can learn about their particular industry. And coders will be relegated to writing code that connects that black box to the outside world, because the outside world is not yet fully up to speed with let's say, automatic processing of stuff. And so we will still need people to connect the brain of that company to the outside world by what I would say 4 channels: data coming in, data coming out, mining coming in, mining coming out. And so in that sense, it will definitely kill most of the programming that is that previously would go into that central brain of any company. That's my thesis.
Okay, and right on time, Gene, thank you. And our next speaker to go arguing against is Brian Cantrell from the Oxide Computing Company. So Brian, please introduce yourself and, let Gene have it.
Hey everyone, I'm Brian Cantrell. I'm the CTO of the Oxide Computer Company. We actually still do program in assembly, but not just assembly, obviously higher level languages as well. We in particular are doing a lot of things in Rust. And I am, just to be clear, AI is not my domain. I have been an AI malcontent and conscientious objector for my entire 30-year career. But I have done systems programming, a lot of systems programming, and I've done a lot of systems debugging, and have seen as part of that how frail our systems are. These are mathematical systems, and a single defect in a complicated software system can induce really outsized pathologies. These systems need to be exactly correct. They're very finicky. It is garbage in and garbage out. That still remains true. And I think as we talk about how can AI affect programming, will AI become as essential to the programmer as things like source code control and these other innovations? I think the term we actually most need to define is AI itself. AI is a terrible term. It has always been a terrible term. And I think that we are much better off thinking not of artificial intelligence, which immediately thinks of us to think of the computer as being like a human, and much more in terms of automated pattern recognition. That is what we think of AI is actually automated pattern recognition. And if you substitute automated pattern recognition into the sentence and the sentence does not make sense, then it's probably not going to be true. So I think that what we're actually debating here is, will automated pattern recognition become as essential to the programmer as source code control, continuous integration, and so on, these other developments? And I think automated pattern recognition can be helpful, but I think when you think of it that way, you immediately begin to think of it not as replacing the task of programming, but as dealing with those particularly data-intensive aspects of programming. There do exist data-intensive aspects of programming, but in my experience, they are few and far between. And certainly there is a plethora of data that exists out of our systems that we don't actually really process, this kind of internet exhaust that we don't really meaningfully do anything with from a programmatic perspective. And maybe we would do some things with that. But as I look at the systems that I develop, the questions that I have are often much more precise than automated pattern recognition would afford. I am not doing the kinds of things that certainly when I'm in the act of programming, I'm in the act of cutting code, it's very high consequence. It has to be correct. It can't be approximate. This is not identifying a picture of a hot dog where the errors are not necessarily a problem. I also, when I am writing code, I need to have my own explainability. I need to be able to explain why I'm doing this. And the current state of the art in automated pattern recognition is very little explainability. Now, this is becoming, I think, increasingly a problem. Historically, when you're doing image recognition, which is something that AI has absolutely excelled at, its ability to misidentify an image has not necessarily been high consequence. That is becoming increasingly high consequence as time goes on, but we don't really have the ability to understand, why did you get this one but miss this one? When we are programming, those systems are so precise, we really demand that explainability. And that is not something that AI is really on a trajectory to deliver. So from my perspective, where we can expect AI to actually impact programming, it is where there are patterns to be meaningfully recognized, where there are large data sets that can be trained and so on. And I simply don't see that in most of what we call programming today. So I do not think it is going to have this kind of outsized impact.
Awesome, and right on time. Thank you, Brian. And the next speaker to argue for is Omar Alonso. Just before you begin, Omar, please, if you have questions that you want to submit the next round after all the speakers are done arguing their point, we'll be using your question to ask them to clarify their positions. And Omar, please go ahead, introduce yourself, and kind of argue your point.
Hello, folks. Thanks for watching. My name is Omar. I work at Instacart. I just joined Instacart a few weeks ago. Background is mostly information retrieval, knowledge graphs, and large-scale labeling. Before that, Microsoft, Amazon, and Oracle. All right, so why I'm bullish about using AI for improving programming at large. I think there's tremendous opportunities to build new tools that are going to augment programmers. And this is going to partition the set of programmers who are very skilled and the ones that I think are going to disappear. What I'm trying to do here, what I'm trying to say here is that there are certain things that we can always improve. And if you can build tools that recognize these patterns, as Brian was mentioning before, if you think of managing a file, you're going to read a file, you're going to open the file, do something, and then write back. If you're thinking in terms of a database, you open a connection, you lock a record, you do something, you release the lock, and so forth. And the same with memory management. You allocate a pointer, do some stuff, release the memory back to the heap. A lot of the bugs that you can see in coding today is because people do not follow these protocols, right? So I think there's tremendous opportunities for building tools that can learn the behavioral patterns of programmers, not just looking at the code, but see the behaviors. And as you know, Microsoft acquired Git some time ago, so there's plenty of data to build new tools. So I'm really hopeful that the new set of IDEs are not going to just suggest you syntax, but I think we're going to have better tools that can predict potential behavior, common behavior, and just hopefully help the developers. Why I think there's going to be a break in two types of developers, because the ones that are well-trained and know algos and all those things can benefit from this new set of tools. And the ones that are just doing initial hacks are going to struggle, because you may not be ready to use these sophisticated tools that require serious coding. So yeah, that's my perspective. And no, I think I'm more like just to summarize, I'm more hopeful on tools that are going to augment developers, the good developers. And I think those tools are going to be a very high bar if you are not a very skilled programmer. That's my argument.
Okay, and thank you, Omar. And kind of last but not least, arguing against the proposition is Helena Edelson. Please introduce yourself and tell us why you don't believe that AI will kill programming.
Okay, hi everyone. Helena Edelson. A quick intro about me. I started out mostly as I've been a senior cloud engineer for years at various companies around Silicon Valley. Worked in many different domains, cybersecurity, cloud, infrastructure. Been a senior distributed data engineer and platform engineering at Apple, and a VP of platform engineering at a startup and principal engineer at Lightbend. So I've seen a lot of different domains and applications of machine learning and AI in those different places, and different approaches and different experience levels of the teams, and also very importantly, different funding of those teams and the different importance of what those teams are doing and the business plan of those teams. So, so this is a really interesting topic. What I'm doing now is that I'm sort of bridging I thought I left tech. It turns out I really didn't. I'm kind of bridging academia and tech right now. I'm starting a startup, but I'm also sort of part of involved with the Oregon State University, but working a lot with the endangered species and conservation groups, working on issues related to climate change and things like that. So I'm looking a lot at very different types of data, very different constraints, and how to pull this all together, taking what we all know how to do in tech and sort of layer everything with climatic data and species data and image data, like hundreds of thousands of images of species, and trying to identify the species and identify the individuals, and all of this sort of AI for good. And so how I feel about this, I think, well, first I have to thank my esteemed colleague and teammate, Brian. Excellent. Totally agree with everything that you said. That was really well put. I also see AI largely as an optimization tool, particularly from where I'm coming from now, which is sort of an and to what Brian was talking about. I think we can all agree that AI helps us do more with less. And so a lot of what I'm dealing with is collaboration with scientists, for example, where I see, well, first of all, AI in terms of how its relationship to, will it become essential to programming with regard to code control, continuous integration, languages. That's already happening. So I see it kind of as a foregone conclusion. For example, Microsoft has that as a service. Seems pretty mainstream to me. Essential, I think, also is a strong word. I think caffeine is essential to programming. And so since it's already in place, I think what's really going to happen is a transformation of programming with AI. And so what I mean by that is the boundary, first of all, between programming and AI is falling away. as similar things have happened between sort of big data and data science and programming, but really the boundaries of all this is just disappearing. And I can go into that a bit more in the bulk of what we're going to talk about, but I mean, it's data scientists and machine learning experts learning to code, researchers and scientists learning to code, programmers learning to do data science, and it's just all starting to blur. But there very definitely is things that are specific to our domains where a data scientist and a researcher out in the field is, studying ice melt, for example, is not going to be an expert in scaling up or productionization of these systems. But also, it's going to be opening up, when I say transformation, I mean, it's going to be really, really interesting to see the scientific collaboration and the innovation around that between programmers working more and more with scientists to try and help with some of the larger, more urgent issues. And I think there's going to be more of I think over time, we're going to see more of an exodus of people like myself that are leaving industry and going to see what they can do, how they can apply their skills to help solve some of these problems globally. But I have to bring in this one last point, which I think is sort of a reality check, which is something I've seen year after year everywhere, that is of money and funding. AI for engineering for infrastructure, like we're talking about the specific context, to me, I think sounds like technical debt to a sales team. And sales teams are largely drivers of budget allocation and resource allocation. So unless they can sell it, it's really not going to ever be important enough to be something that you're going to throw an engineering team on. It's always going to be like, hey, we need to put our resources towards these new functions or what our customers want, or how are we going to solve our scaling issues better? It's always seeming to be that versus doing this infrastructure work.
And awesome. Thank you, Elena. It's unfortunately there is, or I just don't know how to kind of give you signals around time. So we'll just have to jump in at certain points. But this kind of concludes our kind of first round of the debate, where the debaters kind of made their opening statements. The next kind of portion, I'll give you some questions, both from myself and the audience. But kind of just to recap, we heard kind of Jean and Omar kind of argue that really we already seeing AI pretty much everywhere, whether we kind of call it programming or not. Is a moot point. And if we think about programming as kind of a set of small deterministic tasks that humans tend to err on, actually this is something that is suitable for machines, and there are already plenty of examples. On the other side, the team arguing against mentioning that AI is really kind of an optimization tool. It's more about pattern recognition. And really, the software engineers' work is way beyond, just taking these small deterministic tasks and, kind of repeating them ad infinitum. And there is a limitation of what can we achieve using kind of these AI techniques. So maybe kind of first question to go for the team arguing against. So part of the proposition is saying that AI is not necessarily will replace all of engineers, but will become an essential tooling, like we said, memory management, source control, and so on and so forth. So why kind of don't you believe that maybe AI or systems that have kind of AI is an integral part of them will not be kind of these auxiliary systems that are essential part of the kind of tool chain that engineers use on a daily basis?
So that's a question for the against side. So
yes.
I'll take the first swing at that. Well, so I think that, and my teammate, Hannah did a very, I think, a compelling argument about how more and more data intensive domains are going to be engaging in programming, which is kind of the inverse of the proposition here. And I think that I emphatically agree. I also especially agree with the point that more and more folks are looking beyond the traditional kind of tech domains and looking for larger impact. They're going into the world, looking at things like climate change, and finding a data intensive world that they need to understand programmatically. So they end up applying all sorts of pattern recognition tools and so on to that data intensive world. But that's the inverse of the proposition here. The proposition here is not that we are going to provide doing more and more programming in a data intensive world, but rather we will be applying these techniques to the actual act of programming itself. And what I do not see the big data in programming. I don't see it. Now, admittedly, on the systems that I write, I am very concerned about their resource utilization and so on. But I don't routinely process gigabytes and terabytes and petabytes of data as a programmer in the act of programming. I don't think you can call a Google search on Stack Overflow big data. That is not actually, and that is about the time when we use the most amount of data. I don't see us doing that. So I think that I would kind of flip it around. When a programmer is programming, what is the large data set that they are querying to actually engage in that act of programming? I don't see it.
Yeah, so Gene and Omar, Brian makes a compelling point, Brian and Helena, where they argue that, as we see increase in AI capabilities, we actually see more and more demand for programmers. Like if really the proposition was correct, and not to pull words in your mouth, we would expect to see the opposite impact on the demand for programmers and programmers. So how would you respond to this statement?
Do you want me to start?
Whoever wants to go first.
Well, I mean, as we all remember, 200 years ago in New York, there were predictions about horse shit filling all the streets to the tops of all the buildings. So that's the equivalent of too many programmers, and then the more and more programmers needed. I mean, if we take the slightly longer view and acknowledge that a physical system is capable of thinking, the proof is in each of our heads. And then we look at the density of computation that's available today and notice that it's probably 2 or 3 orders of magnitudes away from the density that's realized by neurons in our heads. The argument becomes not if, but when. To redefine AI as pattern recognition is convenient for the argument, obviously, but look at GPT-3, look at AlphaGo, look at image generation. It's way beyond pattern recognition. And of course, there always going to be something like the Swiss watch today. It's a mechanical system where one tiny mistake invalidates it. But already the cheap quartz watch is so superior functionally to the $50,000 piece of jewelry. I would say that we will probably not even see the inflection point between the need for more programmers to deal with horses produced by all those horses 200 years ago in New York, and the situation when many people suddenly find themselves not needed to code even the most mundane tasks. So I don't think it's a valid argument to redefine AI as something it's been maybe 100 years ago or 50 years ago. It's so much more than that. Maybe you don't know, but the number of knowledge in the space doubles every 3 months right now in artificial intelligence publications and advances and new models. Where even 5 years ago it would double maybe every year. The humanity is notoriously bad estimating exponential processes, and I think we're just starting the inflection point. So what looks to many people as a linear growth is nothing but.
Okay, that's also an interesting point. Maybe Helena, you could respond. Let me kind of paraphrase a little bit of Gene's statement. So, and maybe provide a little bit of context. We already seen demos from GPT-3 where people can input literally a phrase of "I want," a website with 2 text boxes and a red button and things like that. And GPT-3 goes and generates kind of the front end and some back end kind of prototype. So what makes you and kind of your team have a high degree of confidence that 10 years from now, which is kind of the time frame we're talking about, we will not see this kind of simple demonstration to become actually something very real?
Well, I have to caveat, I've not worked with GPT-3 myself, but I think the danger we could get in here with these discussions is the oversimplification of this. So a lot of the examples are games, complicated games with complicated decisions that it has to make, but still simple. Or if we're talking about things like pattern recognition and yeah, like SpongeBob or something. I mean, that is not actually how it goes when we're trying to do a large scale image recognition project. Humans are largely involved in that. They have to go through and pre-identify when you're trying to first put together the images to train the AI so that it can learn how to do the job itself. And so you need programmers to, or interns or whatever, but you need humans to go in and first work with the data and teach it what it needs to learn, or you know what I mean, pre-allocate what it's going to learn from. Sorry, and my whole premise for this of saying no is that it's not going to kill programming. It's not going to take away the jobs. It's just going to be more of a transformation on what we're doing as programmers.
Awesome. And maybe kind of back to you, Omar, one also point that was made and kind of by the team arguing against and kind of appeared in the question is really, if you look at the programming job today, if anything, we go into more and more kind of higher depth of understanding what is actually going on. If you look at the kind of the observability kind of movement that has been happening in the last several years, and now we have a company like Datadog worth like $20 billion. People really want to understand every single bit of byte, while on the other hand, AI kind of takes us in almost like the opposite direction, where we now have these extremely complex black boxes that generate output, but no one, no human can understand what actually is happening between. So how can we actually replace programmers where it seems like we're trying to get a higher degree of confidence around how our system operates, while it seems that we actually kind of losing more ground to understanding how AI works?
A number of observations here. The first one is I want to address the issue that why we're getting more parameters instead of less parameters first. And one of the reasons is I think we're doing more computationally thinking, if I want to borrow a phrase from Jeanette Wing, where there's a lot of problems today that they can be solved by just programming. This is not just for computer scientists like ourselves, but for a lot of other disciplines as well. So the use of a machine to code to solve a problem is pretty much mundane. Anybody now takes a programming class because you have to solve a particular problem. So parameters, the number of parameters actually increases. That doesn't mean that AI is not going to help you, or there's no good AI techniques that we can use today. Explainability, well, again, depends on the kind of computationally thinking problem that you're using. There are certain problems that you have to explain. There are other problems that are going to be more difficult to explain. Hardcore, ML neural networks, very hard to explain. Others you have to explain. If you're going to build an autopilot, which is basically AI for flying your plane, pretty critical that you explain what's happening. And the last point I want to make, which I think Elena was saying, that yes, there's always a need for a human. That's just not for just labeling your images, but there's a lot of techniques that you need a human to actually produce the computation first, so then the machine can learn. And probably one of the biggest examples, and this is not AI, but well, we want to call it AI, but if you think of like parser generations like, Yak, the famous tool, those were done because someone actually wrote one, and then they wrote a program that actually writes that thing. So it's kind of two levels, kind of meta, right? And those things are happening. So the ability to generate code, not just as a compiler, but also, configuration files and little languages are all examples of different type of AI. That you take knowledge, you absorb, you synthesize the knowledge, and then you write a program that actually behaves like a human. So from that, it's pretty much everywhere.
Well, awesome. And, this concludes kind of our second round of this debate where kind of the panelists answered the question, both kind of for me and the question that were posed by you, the audience. We're going to switch into the kind of third and final stage of the debate where the debaters will kind of make their closing statements. Alexei, if you can, please share the link for the voting. So while people kind of making their statements, if people are already decided kind of one way or another, they can start voting in case we have some technical issues around it. And let's start the opposite way this time with the team kind of arguing against. Brian, maybe start off with how you want to conclude your position on it. And here is a kind of a tip for all of you folks. Your statement should end with something along the lines with, and this is why you should vote for or against the proposition. So
right.
Go ahead, Brian.
I'd like to start. Can I start, Brian?
Sorry, go ahead.
Sure, absolutely.
Yeah.
Please, yeah.
Let's talk about that black box idea. That really struck me. I mean, realistically, first of all, I have to say that this was a really hard thing to do because I'm able to argue both sides. And so, it's very touch and go. But on the black box idea, first of all, who do we think is writing the box and writing the code that's inside that box? And who do we think is writing every single logic change that has to be rolled to that box, tested, and deployed to boxes all over the world? And so what was the closing we're supposed to use? That tagline. And that is why I think you should vote no.
Okay, awesome. And who wants to go between Omar and Jean to kind of if your closing remarks?
I'll go first.
Go.
I go first. I think for developers in general, I think the tools have gotten better. Your IDEs now have autocomplete. They will just highlight the changes. They will tell you not just your syntax bugs, but also a few other things. There's a lot of accumulated knowledge, not only on obviously Stack Overflow and Core and all those places, but also in source code. And there's a lot of potentials here for new tools that are going to help you, not only in terms of productivity, but also do the boring things that nobody wants to do. And I think the machines are going to be great for that. So remember to vote yes, AI will dominate.
Awesome. And Brian, how about you going next?
Well, I think in those arguing for this, we have seen the classic trap of AI for time immemorial, which is because our brains are physical stuff and we clearly have thought and intelligence, and computers are physical things, we must be able to make computers intelligent. And it ignores the fact that the computational model is entirely different between the silicon and our actual brains. We look at we have had since the 70s, we've gone from thousands of transistors on a die to tens of billions. And over that time, we have not fundamentally changed the computational model. Computers do loads and they do stores and they do branches. That is what they do. It's a von Neumann model. And the tricks that we have pulled, which are very impressive around automated pattern recognition, are exactly that. They have not made us more intelligent. And Helena made a very important point about the hidden humans behind these systems. These are the humans that actually tag data sets. If we do not tag data sets, the computer actually doesn't have the capacity to reason about it. It is not intelligent. And if the data set is not tagged, it doesn't know how to identify it. If you have a toddler, if you've had children, and you watch the way they learn, you know how fundamentally different it is. We do not teach a 2-year-old what a cat is by showing it 10 million images of different cats. A 2-year-old that cat around the house will be able to identify a cat that they have never seen before that looks different from their cat, but is clearly a cat. A 2-year-old is able to do this because the computational model in our brains is entirely different. We are not on a trajectory to do that with silicon. And AI continues by the arrogance of its name, it continues to deceive the general public about its capacity. We are not building intelligence. We are building automated pattern recognition. That automated pattern recognition is important, but it depends ultimately on humans to seed those data sets. And I don't see that happening in the act of programming itself. The act of programming itself is like math, like theorem proving, like writing, is an act of, honestly, of extraordinary intelligence. Not to overly praise us in the room, but programming is hard. It is essentially human in its endeavor, and I do not see automated pattern recognition assisting or becoming essential in the act of programming in the next
Right,
decade.
and this is why.
And this is why you should vote against the proposition.
Awesome. And wrapping up the closing statements, Gene.
All right. Well, I'm really glad that you mentioned the baby. If the baby didn't have a family, it was raised by wolves, it will never recognize the cat. In fact, pointing out that the computational model at the base of modern computers is not the same as for human brains is really mixing up the levels of abstractions. It's like saying, look at neurons. You will never be able to explain human thought if you just count the impulses that the neurons send to one another. In fact, the way we're teaching intelligent systems today to do what they are capable of doing, or maybe in some cases we make them teach themselves, like in the case of AlphaGo, is very analogous to the way a human baby is growing. And the role of those programmers who need to code the initial data set is the previous evolution that created the hardware inside our brains that is capable of being taught in the gestation period of a human mind, which starts before birth and ends in some cases at 30 years old or older. Sooner or later, the computational intensity of any physical system will be sufficient for the emergence of thought, what you said, of very high intelligence. All that's missing really in that area is goal setting and the I would say the survival goal of the system. As soon as we teach the system some overarching goal and let it develop and absorb the information from the outside world, it will definitely become as intelligent or more intelligent, if it's possible actually, than humans or any other life form. And that is why you have to vote for our proposition.
Well, awesome. Thank you, folks. I really enjoyed the debate, and thank you so much for, making the most out of it in these kind of unusual circumstances. So I wish there was a live audience and we can kind of get a big round of applause, but I guess we'll just have to imagine that, it happened. It is happening. So now we're going to kind of tally the vote, and I'll share with you. So everyone who hasn't voted yet, please vote for your position. Again, I don't know if it's too soon, but we won't have absentee voting in this in this debate. So please make your voices heard. Kind of, will AI kill programming? At the beginning, there were 39 responders, and actually 82.1% answered no. So it's clearly kind of a highly technical kind of audience that is not necessarily my guess that is in an AI conference, the results would be somewhat different. But here I see where people kind of stick to their guns. So the 4 team had really, their work cut out for them to kind of try to swing some of these votes. But if we see here, and there are still votes coming, so I'll give it like it's actually see it like updating live, and it's actually fairly close. So I don't want to. I'll let people to kind of finish.
Recount.
Yeah, finish the voting. So we won't have
need
to.
like the MSNBC, the number guy.
Yeah, we need the more
The
guys. So.
statistics,
By the way, if anyone wants to reserve the 4-season total landscaping for making some statements about how the vote should have been, then maybe that's a good time to give them a call, because I think they're probably very popular. So I'll put a timer in kind of 1 minute, and then I'll stop. I guess we're at 30 responses now. It's, oh my god, so it's 40 responses already. So please keep them coming. I'll put a timer, 60 seconds, and after this timer, whatever the result is, I'm gonna read it. It's so. By the way, congrats to both teams who probably did a kind of great job on making the topic interesting. And maybe in this kind of 60 seconds, who wants to kind of maybe respond? How was it for you folks? Did you enjoy the format?
It was good.
Awesome.
Yeah, I think it was hard, especially like if you could argue both sides, and the way, if I don't know if everyone realizes that some of us argue, not necessarily how we feel strongest. So it was pretty fun.
Yeah.
Some of us are unable to argue both sides.
Yeah.
Let me guess your
I
real
convinced
position.
myself though.
So actually, I don't know if I can share maybe my screen and actually like show you, so don't like people not get accused of kind of the vote. So this is the before vote, and now my timer just rang. So can you see my screen here or not? So this is the before vote, 82.5. I guess some people added the before vote even after this, and the way we ended at 39. Sorry, this is the. Oh, wow. So folks, I think it will be only fair if we conclude it as a, maybe kind of a draw. It's like actually like it is within people. Oh, I guess people are now seeing the screen and adding more. But you know what, we can now split hair and claim that this, 1%. But I think if, we can call it as a first time in Scale by the Bay, something that is coming close to a draw, or people coming with vote after. But like I said, we put a timer. It was like literally less than 1% change on each side. So I'd like to thank again everyone who participated in it. Folks, you've done a great job. I enjoyed it greatly. And Alexei, would you like to add kind of final words?
Yes, first of all, I must report certain voting irregularities. We detected certain suspicious patterns. So what happened is I kept track of everything, right? So so before is supposed to be really before. We asked folks not to use the panel inputs to change their state. So when Vitaly, and I don't know if it was a voting mistake or not, but basically the original vote was 77% no, roughly 23% yes, right? So after the most powerful statements for the no side, I would say we have about 5%. So what happened is when the after vote was declared, the counts started going on both. So you might argue, depending on how you see it, right? Maybe people were recording the original impressions from the best of their ability, going back in the time machine. But there is you can interpret it as a slight change in favor of no party, right? So I would say that's one way to interpret it. But again, it is pretty close, right? And yeah, it's actually now going to almost 83%. The good thing is that we have about 48 votes after versus 40 votes before, so we certainly increased the voter participation, which is a great achievement for our democracy.
Yeah, so
I would say that people's minds are already made up, and both teams did a good job throwing red meat to their base.
Yes, that is probably, a good way to summarize. I have to say that also, since kind of somehow there was kind of this weird part where at some point, actually the red part was, which represents the no. And again, this is not to draw any political conclusion. This is how Google Forms decided to color it. It was 100%, and then there was
Yes.
like this. Then there was this blue wave that came in and swept the votes to the other side, which was kind of a little bit too soon and kind of too close. And like I think now people will start seeing these patterns. Everywhere. But yeah, I had to like, it was kind of so funny as there was like 100% red, and then like the absentee vote started coming in, and the blue section arrived. Yeah, the mail-in votes arrived, and the blue section started growing and growing and growing. But I think still like I said, maybe not enough to actually kind of swing. But if the original one was 77, I think now people kind of relaxed on 84 with 50 responses. So again, both teams did a great job. Probably like one of the things when you do it in live, you can actually see the difference between the absentees as well, like because usually large portion of the room does not kind of vote, and then you kind of start seeing here. It's hard to say how many votes have been actually swung, but there's at least 10 more votes that didn't appear in the initial vote. But the problem with them, they kind of fell very similar to the original voting.
Well,
awesome.
you know why this is happening, right? The AI is smart enough to keep most of humanity in the dark.
Yes. So yes, Alexis, so what's next?
So first of all, we have Q&A in this format, right? So after we are done here, there is a link. Don't click it yet, but there is a link in the Zoom chat. If you click on it, you will get into another Zoom, which is open to the public. This is the Zoom for the panelists and speakers, which is not open to the public, but after the panels, we have an open Zoom, so you are all welcome to go there. One thing I wanted to ask you, Vitaly, if you want to read some of the final thoughts, because the vote forms we shared, the before form had a question for the panelists, and the after form had some final thoughts. I wonder if you want to read them.
Yeah, so let me read them. Sorry, I didn't realize that these are kind of final thoughts. Yeah, there are final thoughts and everything. So kind of very quickly, so will AI be trusted and actually used by humans, question mark, if they're aware open source software is an example, requires several skilled programmers to keep it usable and desirable. My argument is that humans will not accept, in parentheses, knowingly, AI generate machines / code, so it will not kill programming. Then someone said, I'd like to understand how AI, how is capitalized AI can assist us, not this far-fetched sci-fi idea. That's interesting. I wonder which side this person was on, but it will definitely assist programming. That is something, another comment. Then there was another comment. I expect to see some displacement of programming jobs in the next 10 years. I expect to see an order of magnitude more displacement after this talk. That's very interesting. I think developers will figure out how to make AI explain / reasons behind its decisions. Baby learning can be compared with reinforcement learning techniques. Then there is it'll change the nature of programming in some areas, but not kill it. And in parentheses, although Gene does make a convincing argument. So that's our first call out by name. So good job, Gene. The question is too binary. Well, we have two teams debating, so I'm not sure how we could have like improve it by making it less binary. And the other, it will kill some jobs, but will create more. The evergreen anti-Luddite argument there as well. And then someone said, but it will take a long time. That's it. And then the final, I guess, nail in the coffin is humans will die first. That's somewhat a morbid view on humanity, but who knows with COVID and all of that. Then it might take a decade, but I don't see a reason why not. And I think, yes, I see there is less common. Simple things can be done made by ML, but simpler programs can be written as well. Yeah, it's kind of unfortunately, it would be nice if these were tied into the votes, but I guess, yeah, I can see them individually, but it's kind of, well, I guess Google is not very known for their top UX chops, so it's very hard to kind of triangulate the comments to how people voted, but you heard here. So now we're going to this full Zoom inception, Alexei, and going like.
Correct. Let me just read one last question from Discord, which I think is a very good angle on this vote. It basically says the vote just confirms that 80% of the people need to work harder on making AI kill programming. So with that, let's proceed to the Q&A. Just click the link in the chat.